you meet your master teacher chemistry, Shushmita Singh, and yes, you all can call me your Shush ma'am. So let me tell you about the credentials. So I've done my bachelor's and then also I've done my master's and tried to bag the silver medal. So yes, I will also tell you that I have mentored as many of like 25,000 plus students. So I would just tell you that if we come across the chemistry, we find certain kind of magical instances. Right. Now let me show you some examples out of it. So here you can see two examples, right? One is the tea bag diffusion and the other one is the pruned fingers, the wrinkled fingers, right? Now, if you look into this, that how this tea bags just diffuses all that particles across all the water that is placed in the cup. How actually this happens? What is the magic behind this? Is there any? Let me tell you the mystery behind this. Now, if you follow with this, I will just take an example of just we all are having this example as per daily basis. So if you have come across this Maggie, right? Now it is going to be like, yes, we need to rush in where you are in your study room, studying or doing some activities, and your mama is preparing, or your brother, sister, somebody is preparing Maggie in the kitchen. And suddenly you find that, yes, some smell is coming, the aroma of the Maggie, and it attracts, and we are just pulled towards this. Now, why this happens? How these Maggie smell reached to you? What was the reason behind this? We need to know about this. Why this phenomenon happens? Now, let me just give you one more situation where you have will find out that yes, this is gonna happen. Now you are just about to get ready for some party and you're just about to spread the smell of the perfume, right? Now you're going to get that smell. Okay, okay, perfume, nice, nice. And suddenly your mom enters into your room and finding that where they are planning to go. Now, how the particles of the perfume reach to your mom's place? That now here might have has happened. So if you look into the particles nearby you, it is more. Okay, fine. Now what was there which made it to travel to your mom's room? So is there having any kind of vehicle or what? No, there are something. The gases will take this particle from the region of the higher concentration, from the region of the more concentration to the region of lower concentration or lesser concentration, right? So if you look into the further examples also, you will find out that, see, now this green balls are more here in the bottle. Now what is happening? It is starting getting diffusions where there is no green particles. Why this happened? Again, the question arises, why this? So I'll tell you that in this, we do have the process of diffusion. Taking the example of these smiley balls. Consider this as the molecules or the particles. Now, if you see, what is the concentration of the molecules on this side? The smiley balls, the smiley molecules. Of course, you will say that, yes, ma'am, we are having the molecules of the smiley at this side more. Now, what is going to happen? They're going to just rush. Where? To the region of the one where it is having lower concentration or no concentration. So the movement, if you look into this, you will find that this is going to move from here to this place, right? So yes, let me tell you one more of this, that the movement of the molecules from the region of higher concentration to the region of the lower concentration or lesser concentration is known as diffusion. Please mention this point, that the movement of the particles will be from the higher region towards the lower region of the molecules, right? So you got to know what is diffusion. Now, I was just planning to make a biryani, though I'm not so good, but still, I called two of my friends and Nihal was nearby the biryani, whereas Manan was little bit far away. So can you just tell me that who is going to smell the biryani first? Who is going to get the smell of the biryani first? If you look, that Nehal is towards the region where the concentration of the biryani smell is more. But if you see that Manan is bit far, so it might take some time for the biryani smell to reach to his place, right? So we can say that the particles diffuses from the region of higher concentration to the region of lower concentration, right? So who is going to get the smell of the biryani first? I want to know the answer in the comment box. Yes, do answer it. And that's good. I can see. Yes, of course, Snail is going to get the smell of that very first. Now, if I am taking you to the laboratory and I ask you to just put a color salt, right? We are going to put some colored salt here. If you look into this, you will find that this is going to be the one, this is going to be the one where the concentration of the salt is more. But now, readily and slowly, what happens? It is going to diffuse all in the water. And lately, you find that yes, all that salt particles got diffused. Right? How this happened? Now you have the answer, right? You can say that, ma'am. Yes, we do know that what has happened. The movement of the particles from the region of the higher concentration towards the region of lower concentration, right? Moving forward, if I ask you this statement to state is as true or false, what would be your answer? So diffusion is a process that only occurs in liquid substances. Is this true or false? What will you say? Come on, I need your answer. Come on, tell her. Come on, tell me. What should be the answer? So here, what we can find? That it does not occur only in the liquid. It occurs in the liquid, it occurs in the gases, and let me tell you that yes, it does occur in the solids also. And now I will hint you with this that if you look into the rate of diffusion, that what would be the rate of movement of the particles in each of the cases? So the solid is going to have the diffusion at a very slower rate, whereas the gases are going to diffuse at a higher or faster rate. Right? Now I'm going to give you the question you will have to solve. Yes, come on. Rate of diffusion. You have to answer this in descending order. Given solids, then liquid, then the gases, liquid, gases, then the solids, or gases, liquids, and then the solids, or solids, liquid, gases. What could be the answer? Come on, let me know about this. Yes, what should be the answer? Yes. So if we look into this, we get that the gases, then the liquid, and then the solid. So the rate of diffusion is highest in the gases, then the liquids, and then the solids. Got it? Now, if you must have looked into the real life example, we have got that the tea bags. Now, in case of the tea bags, if you look into this, that the particles which are present in the tea bag, right? Now, those tea bag particle is going to diffuse right in the entire solution of the teacup. How this happened? The reason behind this diffusion, right? Sorry, just a moment. Now we have the another one that is the cold drink or the soda drinks, right? What is going to have happen here? If you look into this, the concentration of the carbon dioxide gas is higher where? In the outer surrounding or into this bottle. What do you think? Where is the region of concentration of the carbon dioxide more? Yes, we can see that that is going to be more in the intact bottle. But as soon as you open it, you feel that that is going to diffuse out. Why this happened? Because you can see that the region of higher concentration, right, of the carbon dioxide molecule is higher here and lower in the atmosphere or the surrounding. So it is going to move from the region of higher concentration to the region of lower concentration, right? Got it? Now, next one. Incense stick. We all do puja, right? When? When do you puja? So, of course, we all pray during the examination to get higher marks, right? So, this was a funny case that I might have done. And if you look into this, that what is happening? The fumes of the incense sticks is going to spread all across. Why? Because the particles are going to move from the region of higher concentration to the region of lower concentration, right? So yes, in this way we are going to see that the smell of the perfume, the smell of the incense sticks can just spread all across the room. Yes, we can say that. And why this happened? Due to the phenomenon that lies behind all of these, and that is the diffusion. Got it? Now, contrary to this, we do have the osmosis. Now, what exactly is the osmosis? If you look into this, there is just a membrane that has been added to this. That was not in the diffusion, but there is inclusion of this membrane. Why this membrane and what is the role of this? So this membrane is referred as semi-permeable membrane. What does semi refers to? Half. Permeable, allowance. Then we have the membrane, that is the layer. Now the layer which is going to allow only few of the particles to come across through this semi-permeable membrane, right? So if it allows only few of the molecules, then of course we are going to say that any one of the molecule is going to go across this given two types of solution. I'm going to give you the example of this. What we are going to do, we are going to take the water solution and slowly we are going to add salt to it, and we get two types of solution. One is a salt solution and one is just the water, right? So if we get the water and the other one is the salt solution, so I do have a question for you. If you look into this, that which is going to have the salt concentration? Higher salt concentration. So you will be saying that yes, the chamber A has higher salt concentration, whereas the chamber B is going to have none of the salt. So we can say that it is having no salt in it. So no salt concentration. So what is going to be the movement of the molecules? Yes, we need to know that. Now here a twist is there. What is the twist? That we have added the salt into it. So what would be the movement? So we will see that where is the molecule of water more? Yes, this side. Whereas here it is low. So the water will move from the region of lower salt solute concentration towards the higher salt, which is a solute concentration. So let me show you that free water molecule is higher in which of the following? A or B? What would be your answer? A or B? Where will you find free water molecule more? Yes, yes, that would be correct, correct. That's gonna be the B chamber, right? So the B compartment is going to have higher free water molecules. Now, which compartment has higher salt concentration, A or B? Which is going to have higher salt concentration, A or B? So in this case, we can say that higher salt concentration is in the chamber B or A. That's going to be A, right? So we can say that higher salt concentration in the chamber A, whereas the lower salt concentration in the chamber B. So following up with the definition, you will have to look into the movement of the water molecule. So we will have to say that this is your lower solute concentration, lower salt concentration, but more water concentration. Here there is higher salt concentration, but lesser water concentration. So if I ask you in terms of solute, what would be the movement of the water from a region of lower solute concentration to a region of higher solute concentration? So, the movement of the water from a region of lower concentration of what? Solute to the region of higher concentration, right? Region of higher concentration of the solute. And to mention, that is the semi-permeable membrane, which is only allowing the water to flow, not the salt molecules to flow, right? You have seen this is for both, but what it is allowing? Only the water to move out. So the water is going to move from the region of lower solute concentration to the region of higher solute concentration. Got it? Now I do have a question for you just after this. If you look into this, what has happened? If you look into the water balls and the salt balls. So the semi-permeable membrane allows which of the balls to pass on? What what is happening here? Which ball is passing out? So if you look into this, the water ball has a tendency to move across the semi-permeable membrane and reach to the region of higher salt balls concentration. Okay, so you will have to just tell me that how do you think the water will move? What would be your answer? Come on, tell me. If you have understood osmosis, now you can answer. What would be the flow of the water molecules from A chamber to B or from B chamber to A? What would be your answer? Yes, come on. Yes, we can see that the region where there is less solute. So from there only the water molecules would move. So in this case, we can see that the movement of the water molecule will be from the region of lower solute concentration to the region of higher solute concentration, that is from the chamber B to the chamber A. Got it? Now, of course, you would be saying that, yes, we have got this, and how do you think the water will move? Now you will have the answer. Now you all can answer what it is going to be from A to B or B to A. Yes. So we have got to know that from the region of this to the region of the more salt concentration region, right? Now the real life examples we have got it. So the very first slide we have got the prune finger example. What has happened there? So if you go into a bathtub or if you're taking a bath for a longer tub, you find that there is prune fingers or wrinkle fingers. What might have happened? So in that case, the water, just your finger is going to absorb the water. So your finger might get wrinkled or bloated. So that happens due to the osmosis. Okay. Now another example, if I give you, that is the raisins, soaked raisins. What is the raisin gonna do? Raisins are gonna absorb the water and get swollen up, right? So this is also one of that example where osmosis plays a major role. And salt water gargling. See, when we have a sore throat, when we have a sore throat, what is happening inside? So the tissues are swollen. When it gets swollen up, we find very irritating and very troubling that yes, how it is going to be relieved or how we can feel much more easy. So in that case, what we just do, we do salt gargling, salt water gargling, right? So in that case, if you find that what that salt water is going to do, that salt water is having higher salt concentration, whereas your tissue is having lesser salt concentration. So the movement of water from your tissues will just go out in the region where the salt concentration is more. So the same osmosis applies here as well. And then we do have the example of the contact lenses storage. So if you find that where these, like the liquid that is found in your eyes is of saline nature, right? And if you find the example that the lenses, the contact lenses, that has to get the same kind of environment as your eyes do have. So we find that in the box where you keep the contact lenses, that is also having the saline solution in order to maintain the surrounding of the contact lenses. That also works due to osmosis. So we have got so many real life examples, and we have got to know that yes, there is a lot of mystery of chemistry behind every of the magical experience that we have, right? So if you want to have much more clarification, much more real life examples on different kinds of concepts, then of course you can be here. And let me tell you that there is one of the best innovative live learning app that is with us, and that is the ODA class. So there are very basic process that you have to do. And yes, we are gonna start the course right from the coming Monday. So if you want to be a part of this journey, so please be here. I'm going to tell you the some of the very crucial thing that we have in this journey. That would be your duration will be 1 full week where you're going to have wonderful concept with you. Following with that, you will be getting 3 math session and 3 science session. Along with that, you will be getting the doubt solving session. And of course, let me tell you that you are going to be provided with the personal tutor for all the time. So yes, if you're finding you're comfortable with this, please do join this session because it is going to do wonders for you, right? And of course, there would be homeworks for you. You can do your homework on the app itself, right? So you can just download it right now. And yes, we are just having rush in this. So if you want to be the first come, first or first come, if you want to be the one, so please rush into that. Otherwise, you're going to lose the seat. So what you have to do, just you have to click the link below in the description. So click on this and yes, then you are there. You can just click on this and you will find that you are there in the bridge course. And yes, starting from Monday, you're going to get the utmost brightest concept that you must have come across. That would be your one of your wonderful class. Okay, so yes, you can just get into the ODA class and find yourself much more happier and much more brighter. So you would be able to redeem the gifts also. There are different kinds of gift, smart water bottle, mi band, then you have the speaker, and of course you also can gain this mobile phone, right? So you will have to just come across this and do download the app. And yes, do not forget to just hit the like button, do subscribe this. And yes, if you want to know much more about it, much more about any other concept, so you can just comment down in the comment box. So see you next time. Bye bye.